All right, guys, so this is a little bit new. It's getting you ready for next year. I don't think we're going to include this on the final exam, but you do need to be exposed to areas of geometric figures, and so that's what we're going to be working on. All right, so the first part right here, it says, the areas of basic geometric figures can be found by using their area formulas as shown below. So use these as references when solving area problems. So we need to understand the difference between area and perimeter. So here's three formulas that they're giving us. So area means if we were able to, for example, if each of these were one little unit, a grid, right? And they're 1 by 1 units, how many little boxes would we have inside? So for example, if this was a 1, 2, 3, by 1, 2, 3, 4, 5, 6 by 6, we could just simply multiply 3 times 6 to figure out how many boxes are inside. So we'd have, right, 18 little boxes inside. And that is the definition of area. Perimeter is when you kind of walk the outside and you count. So like 3 plus 6 plus 3 plus 6, okay? So I've seen a lot of us this year in particular kind of not really understanding the difference between area and perimeter. So let's make sure we understand area is what the total area inside the figure. All right, generally speaking, they expect you to know all of these formulas. You're supposed to have these memorized. These are not formulas they would normally give you. So you do need to know that the area for a rectangle is length times width. The area for a triangle is the base times the height divided by 2, or you could say it's 1/2 the base times the height. That's the same thing. And the base and the height have to be perpendicular to each other. So you notice they have to make a right angle. And then the area of a circle is pi r squared, where r is the radius. All right. So it says find the area for each geometric figure. Use 3.14 for pi. So sometimes they want you to leave pi, but in this case they want you to approximate. So since we're going to be approximating, let me grab my calculator. All right, the first one, as we're walking through it, right, they say the area of the triangle is area equals length times width. Here's our length, and here's our width. Since we're multiplying, it really doesn't matter which one's which anyway. And so we multiply 5 times 2, and that gives us 10 square units. Now you always want to put units. They didn't give us units, so then in this case you say 10 units squared or 10 square units. It's the same thing. All right, the triangle is 1/2 base times height, and our base is 7, and our height is 3. And so it's going to be 7 times 3 over 2, which is 21 divided by 2, so 10.5. Right, half of 21 is 10.5. This is 10.5, and you could call it units squared or square units. And then a circle, I'll do the other way too when you leave pi in your answer. They said it's pi r squared, and our radius is 2, right, from the center to the edge. And so that would be 3.14 times 2 squared. Remember that we would square first, so this would be 3.14 times 4. And then using our calculator, right, 3.14 times 4 is 12.56. Okay, this, we could also write this as 12.56 units squared. More often though, they want you to leave pi in your answer. So if we were leaving pi in our answer, the area equals pi 2 squared, which would be pi times 4, or 4 pi units squared. So it depends on if they want you to approximate or give the exact. This would be exact. This would be approximate. Okay, moving on to the next page. Areas of, these are called composite figures. They're not a single figure. So a composite figure can be broken down into basic shapes like rectangles, triangles, or circles. So one way to break this composite figure down is you could potentially break this into two rectangles this direction, or you could also break this into two rectangles this direction. It's up to you. Or you could even break it into three separate rectangles. What I'm going to do, I'm going to break it right here. So I'm going to erase my other dashed line. It's not wrong to do the other direction. I just prefer to do it this way. All right, so let's go ahead and fill in any missing measurements. So to find the area of this figure right here, I'm going to outline it. This is a rectangle that is 6 units this direction by 3 units this direction. And so what we're going to do, oh, they broke it the other direction, right? So actually that's good. I'll go through this direction, this form as well, but let's do this one first. So what I would do, it says to break the figure down into two basic shapes, which I've done. I've got a rectangle that's a 6 by 3, and then I have a second rectangle right here. Now the only thing is I'm missing this piece right here. This piece is not 9 units. This piece, the entire top, is 9, right? I would need to know this piece, and so to do that, I would need to figure out, okay, if the whole thing is 9, and from here to here is 3, then from here to here, right, to get a total of 9, 3 plus what number would give me 9, which is 6. So then it says find the area of the two basic shapes. If you're missing any dimensions, which I was, you're going to find that missing dimension, and then you're going to sum the areas. All right, so I'll go ahead and do their method first, and then I'll do my method. So they have found that this rectangle right here, this is a 4 by 3. So this is a 4 by 3, which is 12 units. This rectangle is a 9 by 2, which is 18, and then they sum those together, which gives them 30 square units. If we do it this way, we were missing this side length. So again, from here to here is 3, and then from here to here is some unknown, but the entire amount has to equal 9. So for that to happen, 3 plus 6 would give me 9. All right, so I would go ahead and find the area of the pink figure, which is 6 by 2. I'm sorry, 6 by 2, and I wrote 12. So that'd be 12 total. And then the area of the orange figure, which would be 3 by 6. And sum those together, and I still get 30 square units. All right, moving on to the next example. It says to find the area of the shaded region. And to use 3.14 for pi. So it says finding the areas of shaded figures, of shaded regions with missing sections. You can subtract the area of the missing section from the whole area. Okay, so for example, if I were to take this triangle and find the entire area, and then subtract out the inside circle, that would give me this portion. All right, so I'm going to find the entire area. So the area of the whole triangle, which is what they say to do, the area of the triangle. So the area equals the base times the height divided by 2, which is 16 divided by 2, and that's 8. So 8 square units. And then I would take the area of the circle. Area equals pi r squared, where r is 1, which would be 1 pi. And then they said to use 3.14 for pi. So this is 3.14. Whoops, 3.14. And then I would subtract these because I'm removing the centerpiece. And so 8 minus 3.14 would be 4.86. So the solution is approximately 4.86 square units. All right, now we have some homework. So remember, this is just basic finding the area. So find the area. They tell you they actually give you the solution on this one, right? Some guided practice. So they said first to determine the base and the height. The base is 4, the height is 5, or the base is 5, the height is 4. It does not matter because we're multiplying. The next one, it says to divide the figure into basic shapes. So I'd probably divide it this direction and find the area of each. So the area of this is a 1 by 2, which is 2 square units. The area of this one is a 3 by 4, which is 12 square units. And then add those together and we would get 14 square units. And they do take you step by step. This one, pi r squared. And so they want you to replace pi with 3.14. So this would be 3.14 times 3 squared. 3.14 times 3 squared, which is 9 times 3.14, and that would be 28.26. And then it says to find the area of the shaded region. So the shaded region, we're going to take the whole rectangle, and we're going to subtract out that right triangle. And so what they do is they find the entire area. That's a 5 by 7 rectangle, which is 35 units. And then for the triangle, it's 1/2 the base times the height. The base is 3, the height is 4. So 1/2 of 12, which is 6. And then they're going to subtract from the 35, they're going to subtract 6 units out, and that will give them 29 square units. All right, so you've got some independent practice here. Again, this is area of a triangle. Area equals base times height. This is area of a circle, right? And area equals pi r squared. And it has given you the solutions here, but what we need to make sure is that you can get these solutions. So, and then this one, if I were to, it's a composite figure, and I would probably break it this direction this time, so I wouldn't have any missing pieces. So you'll have to add these two together. This one, you're going to take the whole circle and you're going to subtract out the little square. And then this one, you're going to find the outside triangle area and then subtract the inside triangles area. All right, that's all the notes for this section. And we're going to have a volume question as well, or volume notes as well. And those will be right on the next notes.